Hi everyone, in this video we solve problem 3.12 from the book Applied Thermodynamics, McConkey and Td Eastop. Here the statement of the problem 12 from chapter 3. Oxygen molar mass 32 kg per kmol is compressed reversibly and polytropically in a cylinder from 1.05 bar 15 centigrade to pressure 4.2 bar in such a way that 1/3 of the work input is rejected as a heat to the cylinder wall. Calculate the final temperatures. T2 means to say T2 we need to calculate of the oxygen. Assume oxygen to be a perfect gas and take CV 0.649 kJ per kg Kelvin. Let me write first the given data that is provided in the statement. The molar mass of the gas is 32 kg per kilomole. Initial pressure P1 before compression is 1.05 bar. The final pressure temperatures P2 is 4.2 bar. Temperature T1, that is 15 centigrade. Add 273 with it to convert into Kelvin. That will be equal to 288 Kelvin. We need to calculate the final temperature T2. Also it's in the statement the heat rejection Q value is equal to 1/3 of the work input required. This is heat rejection, that must be negative. Let me draw its PV diagram. Since polytropic compression is taken place from 1 to 2, it follows the law PV power n is equal to constant. The value of n is unknown. This is here the volume is V1, here the volume is reduced and it is V2. The pressure is initially P1 and reaches to P2 after compression. Now come toward its solution. So we are interested to find the value of T2. Then T2 divided by T1 is equal to P2 divided by P1 to the power n minus 1 divided by n. But here the n value is not given. First we will calculate that and we will put in this equation to find the T2 value. The value of R for the gas constant is universal gas constant divided by its molar mass. For this oxygen we need to calculate the specific gas constant. The value of R universal gas constant is 8.314 divided its molar mass 0, that is 32. After solving this you will get the gas constant value, it is 0.26 kJ per kg Kelvin. From first law of thermodynamics we can say that Q plus W is equal to change in internal energy. The heat rejection value is given, that is minus W divided by 3. I can also write like this: W minus W divided by 3. Take W common. This will be equal to 1 minus 1 divided by 3. Then take 3 as a least common multiple. It equal to 3 and this will be 1. And then finally here it equal to 2 W divided by 3 is equal to change in internal energy. And also the change in internal energy is equal to CV change in temperatures. So I can write that CV divided by TV into T2 minus T1, and from polytropic and also from polytropic war formula W is equal to R times change in temperatures T2 minus T1 divided by n minus 1. Put the values of W here in this equation. I can say that 2 into and just write the values of W in this equation. Is the value of C now CV into T2 minus T1. This is T2 minus T1. This is also T2 minus T1. It will be cancelled out. And 2R divided by 3 into n minus 1 is equal to CV. Apply both sides with n minus 1. So this n minus 1 will be cancelled out, and also divide with both sides with CV. You will get the final expression for n minus 1 is equal to 2R divided by 3 CV. Now just enter the values of R and CV in this equation. R value is 0.26 and 3 multiplied by CV value for air is constant and it is 0.718, and the CV value for oxygen is given, that is 0.649. After solving this you will get n minus 1 is equal to 0.267. Also n is equal to 1 plus 0.267. After addition you will get the value of n, that is 1.267. Now just simply put this n values in this equation. You will get the value of T2. Is T1, that is 288 Kelvin. What is P2, that is 4.02, 4.2, n is 1.267 minus 1 divided by. After solving this on calculator you will get the value of T2 is this press equal button and you will get the T2 value in Kelvin. That is 385 Kelvin almost. That is 386 Kelvin after rounding off. To convert that into centigrade, subtract minus 273 from it and you will get its value in centigrade, and it will give you approximately 113 centigrade, and this is our final answer. I hope you understand. If still there is any confusion, you can ask in the comment section. Please subscribe my channel if you haven't subscribed yet. Thank you so much.